Looking at Algebra 3.1 lesson notes. This is about inequalities and their graphs. So in exercises 1 through 6, write the sentence as an inequality. Let's first talk about what an inequality is. An inequality means it is not equal. You can see the word equal in there. So the prefix in means not. So you will not be seeing this equal sign. Instead, you will be seeing greater than, less than, greater than or equal, which is kind of a combination symbol of a greater than sign and an equal sign. It's like half of the equals, or less than or equal. So these are the four symbols that represent inequalities. All right, so number one, a number x is less than 2. So you're just going to write it exactly how it sounds. X is less than 2. All right, number 2, a number m plus 4. I'm just going to go ahead and write that. M plus 4 is greater than or equal. So that is our symbol that we talked about up here. Greater than or equal. It could be greater than this, or it could be exactly equal to that. 2, 7. Greater than or equal to 7. Okay, number 3. 10 is, this is tricky, no less. Okay, so let's write 10 and let's think about that. If 10 is no less, could it be more? It could. So if it could be more, then it could be greater. It could be greater. That's the greater than symbol. No less means it could also be equal to exactly. So it can't be less, but it could be greater than, or it could be exactly equal. So that's what no less means. It means it's not going to be any less, but it could be more, or it could be exactly equal. Then a number q multiplied by 6. So, by the way, anytime you have a variable multiplied by a number, usually you put the number in front. It's called its coefficient. So actually, I would probably rather this be written like this. Squish them together, which means multiply. So this is a better answer. However, this is correct as well. Or you could have used one of those little x's for multiplied by. Number 4, 4 times the number p. So 4 times the number p, let's go ahead and do that. 4 times p looks like 4p. You can just squish them together. Is more than 22. More means greater than 22. All right, number 5, 1/3 of a number t. So 1/3 times t. 1/3 of t means 1/3 times t. Okay, just squish them together. 1/3 t. 1/3 of a number t is less than or equal to, so less than or equal to 5. All right, number 6. 6 is more. So 6 is greater because it's more. Then the difference, let's think about in math what difference means. It's either add or subtract. Difference is going to be subtract. What's it the difference of? Because we have a subtract now, but I don't know what it's the difference of. It's the difference of a number d and 1. So we've got d and 1. So the difference of d and 1 means subtract d minus 1. So 6 is more than the difference of d and 1. That was a little tricky, but you got to kind of just break it down. All right, number 7 is a word problem. There are 65 people in a restaurant. The restaurant has a maximum capacity of 84. So let's go ahead and start with 84. And let's think about that. If that's the maximum, then can anything be greater than 84? If 84 is the maximum, then it can't be anything greater than this. So it would have to be less than. Now, it could have 84 exactly. It's just that that's the maximum. So it could be or equal to. So 84 has to be less than or equal because that's the most we could have. Okay, and what we're trying to represent is the number X individuals who can enter the restaurant when there are already 65 people there. So we could have 65 plus a number X amount of people, and this number has to be, I think I wrote this backwards. 84 is less than, yeah, I wrote this backwards. So what we're actually looking at, this is how I would recognize if you were doing this, if you did this backwards. Read it from what you're saying. 65 people plus a number, and I'm reading it this direction, backwards. 65 people plus however many more. This is pointing to this way, so it means it's greater, or sorry, it's open to this way, which means it's greater. So this amount is going to be greater than or equal to 84, and that's not what we want to say. We want to say this amount has to be less than or equal to 84. So 65 plus a number X has to be less than or equal to 84. So I definitely set that one up wrong. 65 plus a number we don't know has to end up being a total of less than or equal to 84 people. It's good to talk it through. You can figure it out. Okay, this second section is a little bit different. This actually tells you what U equals, and you need to plug it in over here for U and see if it's true or false. So if U equals 2, then instead of U, I want you to see this as a 2. And then let's figure it out. 2 plus 7 is less than 4. Is 2 plus 7 less than 4? Well, 2 plus 7 is 9. Is 9 less than 4? No, it is not. So 2 is not a solution. So this would be no. All right, number 9. 8 minus x is greater than or equal to 3, and I want x to equal 2. So we're going to plug in a 2 right there. So 8 minus 2 is 6. We want to know if 6 is greater than or equal to 3. And 6 is greater than 3. So it doesn't have to be both. It just has to be at least one. So 6 is greater than 3. So this one is yes. Number 10. P equals 6. So instead of P, I want to see a 6 here. And by the way, that doesn't mean 56. 5 was squished up against P, which means it's being multiplied. So it's 5 times 6. So we're looking at 30 is greater than or equal to 24. 30 is greater than 24. Greater than or equal. So this is yes. Number 11, W equals 3. So instead of W, I want you to see it as a 3. These are squished up against each other, so that means multiply. So what we're looking at is 15 is less than or equal to 12, because 4 times 3 is 12. So is 15 less than 12? No, it is not. Is it equal to? No, it is not. So this is no. All right, number 12 says x equals 10. So instead of x up here, I want you to see that as a 10. This is a negative 10 divided by 5. Negative 10 divided by 5, if you're not sure, use your calculator. Negative 10 divided by 5 is negative 2. So this is saying that negative 3 is greater than negative 2. Okay, think about it on a number line. Here's 0. Here's negative 1 going backwards. Here's negative 2. These are getting smaller as you go to the left. Here's negative 3. So is negative 3 greater? Remember, greater gets bigger this way. Negative 3 is on the left of negative 2. So actually, even though the number itself is bigger, the negative makes it a smaller integer. So this is false. So this is no. This is not a solution. 10 is not a solution. All right, last one of these. 8 divided by y is less than or equal to 6 when y is 2. So y is 2. Let's go ahead and do the math. That is 8 divided by 2. 8 divided by 2 is 4. Is less than or equal to 6. 4 is definitely less than 6. So this is a yes. All right, the last thing we're going to do is to graph these, and we are going to graph inequalities on number lines. So kind of like what I did here. So we are looking at a number line, and I want you to show what it means to have x be greater than or equal to 4. Now, we don't know what x is. It could be 5, it could be 6, it could be 7, it could be 100, it could be 200. It could be 4 itself, because that would be equal to 4. So we don't know what it is, but we know that it's somewhere on our number line greater than or equal to 4. So I want to show that I have targeted 4 on my bullseye. So go ahead and put a bullseye wherever. I mean, you could have put it anywhere on the number line because you're going to number these. This would be 3, 2, 1. This would be 5, 6, 7. Doesn't matter. I usually just put whatever number we're talking about in the center. Now, to show that we don't know what x is, but it could be lots of answers, as long as it's greater than 4, we want to darken in the arrow that's shaded to the right, because that is going to show that it is greater, because greater goes to the right. Numbers as you go to the right get greater, get bigger. And the last thing I want you to look at is the number 4 itself. We're either going to leave this bubble open or we're going to shade it in. And here's what makes us decide that. If x could be equal to 4 itself, then it could actually be this number itself. So we would want to darken it in to show that it could be 4 or anything greater. So we don't know what x is, but this represents that it is 4 or some number greater. Okay, let's try number 16. J is less than 3. Well, first of all, I want to put a bubble with a 3 because that's the number we're talking about here. This would make it 2, 1, 0. These numbers would get bigger, 4, 5, 6. So we're looking at 3. And I want you to represent this number line with J being everything less than 3. Okay, less than 3 gets smaller than 3. So you are going to darken in the arrow that's going to the left, representing J being all numbers less than 3. And the very last step is, do I shade in the bubble? If J was equal to 3, we would, but since it is not 3, it's just numbers less than 3, we're just representing the number line less than 3, not 3 itself. So this is done. Number 17, m is less than or equal to -1. So I'm going to drop -1 on my bullseye. These numbers get smaller to the left, -2, -3, -4. They get bigger to the right, 0, 1, 2. All right, but let's look at -1 itself. This is saying m is less than or equal. So less than gets tinier. Those numbers that are less get smaller, so it's shaded this way. And because it could be equal to -1 itself, I do want to shade in the -1 itself bubble. That shows this, we don't know what m is, but it could be -1 or anything less than -1. All right, last 3, number 18. Okay, this is where it gets a little tricky. You need to read from the variable to the number. So I'm actually reading, normally you read a book from left to right. I'm actually reading it from right to left because you want to start with your variable. This is the thing we don't know about and we wonder where it's at on the graph. So T is, this is greater. This is greater. I know if you read it from left to right, that's -3 is less, but I want you to start at the variable side and read to what it's saying. T is greater than -3. So let's drop a -3. The numbers to the left are smaller, -4, -5, -6. The numbers to the right are greater, -2, -1, 0. All right, but -3 itself, T is greater. So I want you to shade to the right, representing numbers that are greater. And it's not equal to, so we're going to leave that open. Okay, so be careful how you read it. Read from the variable backwards, or from the variable forward if that's the way it was already given. Start with the variable. Okay, 19 is the same thing. I'm going to start with the variable. Q is less than or equal. If you look at it going backwards, Q, the open mouth is not facing Q. It's away, so it's smaller. So Q is smaller than negative 5, or less than, sorry, or equal. So negative 5, these numbers will be negative 6, negative 7, negative 8, getting bigger to the right, negative 4, negative 3, negative 2. Q is less than, so that's going to go to the left. And it's or equal to, so it could be equal to negative 5 itself. So we want to darken that in too. All right, last one, read from the variable. So W is less than negative 4. So drop negative 4, negative 5, negative 6, negative 7, get smaller, negative 3, negative 2, negative 1, get bigger that way. W is less. So we want to shade less, smaller. And it is not or equal to, so we're going to leave that bubble open. And that is it.